Welcome to today's session on artificial intelligence, implications of little philosophy, much science, and lagging policy. In today's session, we are going to talk about the state of artificial intelligence as we see it now. We have a scenario where there is a significant emphasis, or if I may say, overemphasis on coding applications, and there is relatively limited understanding by most of the folks who are creating these artificial intelligences, including apparently at major artificial intelligence companies, a limited understanding of the philosophy and the ontological nature of artificial intelligence. And we also have a policy scenario which is lagging, which means it's playing catch up as it was dealing with technological innovations in the past. It's trying to use the same speed and the same approach, but trying to broaden its scope. And is that going to work? Probably not. And I'm going to share my thoughts on these issues in greater depth over the next few minutes. Briefly, but still, hopefully, in greater depth. So we start off by talking about artificial intelligence, and there's been a jungle of definitions of artificial intelligence, starting in the 1950s, where McCarthy coined the term artificial intelligence, and then he went on to clarify that artificial intelligence, on one hand, the foundational notion was that we are talking about the computer's ability to perform some of the tasks and to display human-like intelligence output or deliverables. And then on the other side, you have McCarthy stating later on that artificial intelligence is not expected to be a simulation of human intelligence. So fast forward to more recent definitions, we have some definitions which are technical in nature, some definitions which focus entirely on the computational ability of what we call as artificial intelligence to produce the results or the functions of human cognition, such as the human ability to hear and interpret audio, the human ability to see and interpret images and videos and real-life scenarios. One of the more what I would call as interesting definitions, a couple of them I've listed on these slides. One is by Rai and others from the field of information systems, where it says artificial intelligence refers to the ability of a machine to perform cognitive functions that we usually associate with human intelligences, and then list them as perceiving, reasoning, learning, interacting with the environment, problem solving, which has been a part of the classical definition of artificial intelligence, whereby the understanding for a couple of decades has been that if we can get a machine to solve problems just as human intelligence would, just as the human mind would, then we're kind of getting better at this business of creating artificial intelligence. And finally, we are at a point where we have technologies that are actually demonstrating creativity, which means you have got AIs which can support, at this point of time, I would like to say it supports or it augments human musicians. AIs can be used to create art. In some senses, it's a modification process because you have to feed in a lot of training images to get a particular kind of creative painting done by an artificial intelligence. Then we have a paper which I myself led, and it's forthcoming, where AI is defined. I would not say that we defined it, but rather we described artificial intelligence as being a collection of technologies, mathematical and statistical models, and a vast array of diverse types of data. So in this perspective, artificial intelligence is like the sense, it is human perception of intelligence associated with a system that contains multiple technologies, such as if it's run in a factory, then we are talking about robotic arms and robotic devices. If it's in the context of a self-driving car and autonomous vehicle, then it's the components of the car, the associated technologies, and all of these artificial intelligences are foundationally running on mathematical and statistical models. It's running on optimization models. And the huge leap, the way we got past the previous artificial intelligence winter, is based on the fact that we developed capabilities to acquire, store, and process vast quantities of the phrase big data. So essentially, we've become much better at that. We have the hardware, we have the juice, we have the capability to do in-memory processing for vast quantities of data. So this technological improvement, along with our ability to acquire, store, and process vast quantities of diverse types of data, has really given a boost to AI capabilities. The second part of the definition speaks about the purpose that seek to model or exceed human intelligence functions or human intelligence capabilities, which means an artificial intelligence which is specifically designed for a specific purpose, such as high-speed stock trading within certain parameters. The AI would be able to perform high-speed stock trading. Algorithmic high-speed stock trading would work better than a human being trying to manually implement that. AI has the benefit of speed. AI has the benefit of consistency. And from a technology perspective, it is completely beyond human capability, for example, to trade 100 times within 1 second or even 1,000 times within 1 second, while that is something that an algorithm would have the capacity to do. So what does that leave us with? That leaves us with an environment whereby we are still trying to define artificial intelligence, and simultaneously we realize that classical questions, such as the question posed by Smale in his question number 18 in his quite famous paper, where he speaks about the limits of intelligence. And he kind of points out that we have not clearly described intelligence in terms of understanding the identity, the nature, and the constitution of it, just plain intelligence, and that's generally associated with human intelligence. Though some people and some experts like to just speak about intelligence generally and then speak about human intelligence separately and machine intelligence or artificial intelligence separately. But the fact is that the question of what is intelligence remains unsolved for the most part. We have multiple definitions. It's not that there's been a dearth of definitions, but we do not have persuasive and conclusive definitions that can be applied across scenarios. So that remains a work in progress. Now, when we look at the definition that I have used or Rai has used or others have used, there are words that we are compelled to use, such as exceed human intelligence functions. But human intelligence functions itself is an area of study we have not concluded. So when we speak about artificial intelligence, developing artificial intelligences which model or exceed human intelligence functions, we are talking about developing artificial intelligences which will perform better than an abstract standard. The artificial intelligences that we are developing, just by the nature of computation, it's very specific. We are able to measure the time. We are able to measure the computational resources that's required. We are able to measure the extent of degree of calculations involved. But the benchmark that we're comparing it, that is human intelligence, it's an abstraction. Artificial intelligences work in a siloed manner, which means we are yet very far away from an artificial general intelligence, AGI, or we're quite far away from an artificial superintelligence that is even more distant. What we have are narrow artificial intelligences, and artificial intelligence which can specifically play the game of Go and play it better than a human intelligence. We can have another artificial intelligence which performs another function better than a human intelligence. But we do not. But when we compare these artificial intelligences with a human intelligence, it's the human side of it is an abstraction, because the human side of it processes multiple things simultaneously, and it does this integration in a far superior manner than we can ever get AI to with our current set of technologies in the current stage of the development of artificial intelligences. When we look at the first definition on this slide, we have similar problems because we speak about perception, reasoning, learning, and interacting with the environment. But when we speak of perception, human perception is vastly different. Even animal perception is vastly different from the perception that we associate with artificial intelligence. Same thing goes with reasoning. Though we use the word reasoning, for example, in the game of chess or in the game of Go, human minds use a combination of reasoning and intuition to play a game. Sometimes, of course, people wing it, which means they're just trying their luck. But that's all part of human intelligence. When we speak about a machine playing chess, it is not reasoning in the abstract sense of reasoning. It is computation. A chess program or an artificial intelligence that plays chess essentially follows certain rules and it explores possibilities. The initial set of programs were completely, if I may use the word very loosely, mechanical in nature, which means it just listed all the permutations and combinations at each stage and selected the moves that led to the best outcomes. Fast forward, today's programs, of course, are based on machine learning methods, which means the computer can learn to play a game. The AI can learn to play a game like chess. But it still does that on, now it's not just a matter of rules, but it's got probabilistic models which enable the artificial intelligence to learn. And still, so it is, if the first stage was, like I said, loosely said, mechanical in nature, whereby it just considered all the permutations and combinations, in the second stage, it is still mechanical part 2 in the sense that it's using a different method, but it is still using the same approach of a mathematical base. So instead of using a deterministic logic, it's using a probabilistic logic to learn and play the game and win, which is very different from the way human reasoning works. For the human entity, so I'll conclude this point with this part, and that is, for the human entity, there is joy associated with winning and losing. For the computer, winning or losing, there's no meaning to winning or losing. It's just a digital process which it is programmed to achieve. So when we speak about reasoning, when we speak about learning, when we speak about perceiving, artificial intelligences do that, but in a very different sense from the way the human intelligence does it. In the early stages of deploying artificial intelligences, these are not big issues, but subsequently, these become big issues when we speak about how we expect artificial intelligence to interact with human intelligence. What should be the position of human intelligence in an AI intense environment? So that's some of the challenges that remain to be addressed. And here's a more colorful slide and a set of thoughts which could take a few hours to explain, but let's see if I can put this into a nutshell and get the key concepts across. First, a classical example by one of the faculty at Stanford, where approximately the story goes as you enter the sentence, "The spirit is willing, but the flesh is weak," which is a scripture verse from the Bible. And so when the human intelligence reads it, there's a certain context, there's a certain understanding, and it's supposed to evoke a good and spiritual sense in you, telling you that the meaning is that even if you have spiritual values and even if you have spiritual inclination, a desire to do good, but the flesh is weak, you have certain human propensities, and you don't always wind up doing all the good that you want to, and you often wind up doing some of the bad that you're trying to avoid. But when we speak about artificial intelligence, this was an exercise whereby The sentence, the spirit is willing, was fed into an NLP system. The NLP system converted it to Russian and then back to English. When it came back to English, for the same sentence, the output came as the vodka is good, but the meat is rotten. And we kind of see the connections. We can kind of connect to the fact that this is how the NLP system may have arrived at this conclusion. We can make that. We can go into the models. We can study it, and we can kind of draw those conclusions. But the meaning is totally different. From a probabilistic modeling perspective, from an NLP optimization perspective, yes, the artificial intelligence did it, and it's probably it's probably got good probability scores with this output. But from a meaning perspective, the AI system has essentially failed, and that is where we see that there is a need for us to understand AI better. Some of the claims by leading companies, such as some time ago, I heard a claim, and there was this fascination, at least in the media. Hey, we got one NLP system, an artificial intelligence, to talk to another artificial intelligence, and guess what? They created their own language. Of course, I didn't get a chance to study it in depth, but from the little that I could decipher, and then I lost interest in it because I have myself run NLG, that's natural language generation models, and generated text. And when I see gibberish come out, I call it gibberish. But in this case, the gibberish that came out was glorified into a language between machine A and machine B, or AI 1 and AI 2. That is not the case, because what we need to understand is that for the human intelligence, language is a representation of meaning, while for the artificial intelligence, there is an absence of intrinsic meaning. And therefore, when we find an exchange of words between artificial intelligence 1 and artificial intelligence 2, we cannot conclude that they're conversing with each other unless we see a purposefulness in it. And when we see such purposefulness emerging, then we would be able to investigate further into the meanings that the AIs are associating. But in this particular example that I was stating, where there was this claim that machines are talking to each other and they've developed their own language, I could decipher no such purpose. It was output from artificial intelligence 1. You can get, even a school kid could use one of the NLG models, run it on a computer, generate gibberish, and set it to feed another artificial intelligence, which would then take that gibberish and produce more gibberish. This is nothing to be excited about. This is something to be concerned about. So it's very interesting that instead of being concerned about output like this, we actually saw this being glorified, at least in the media, and it being promoted as some kind of a development in AI. No, it's demonstrated that in that particular instance, at least to the best of my current knowledge, it appears that there's a problem there that needs to be fixed. So with that, I'm going to, with those examples, I'm going to try to segue into some of the conceptual and theoretical points that I'm trying to make. In the process of developing artificial intelligences, and in the process of overemphasizing coding and methods such as machine learning, we seem to have lost sight of the more fundamental and the more important aspects. That is, we need an ontological understanding. We need a deeper foundation in AI philosophy, and especially in the philosophy of human interaction with artificial intelligences. That will enable us to understand the substance and nature of intelligence and interaction between intelligences. It will also enable us to understand issues such as meaning in intelligence, meaning in human intelligence, meaning in artificial intelligence. What are the sense-making processes employed by human intelligence? How are beliefs developed in human intelligence? And how does it contrast with what we see as we being able to do in the development of artificial intelligences? It will also help us interpret the influence of artificial intelligences on social ecosystems. Society is being transformed by artificial intelligence, and there's no doubt that that transformation is going to continue. It's going to be significant. Lives are going to be impacted. But currently, we don't even have siloed, in-depth understandings, commonly established understandings of AI philosophy and a philosophy for HI's interaction with AIs. That is, when I say HI, I'm referring to human intelligence and AIs. So what's the problem? Let's say we call the philosophical foundations as XA. We call the impact of using AIs as XB, where we have issues such as ethics, dignity, identity, and the corresponding visible effect as YB, where we speak about effectiveness of input, logic and output, data, technology, models, so on and so forth. We speak about YA as being the input logic, where we speak about what is it that goes into AI, and YD as being the final implications, such as we see bias. So once we have issues on, once we see that ethics, dignity, and identity are being impacted, then we are able to draw the implications post hoc, saying that there's bias. So we ran an NLP system, and the NLP system displayed gender bias. So there was an impact on ethics, there was an impact on dignity based on gender, and the final conclusion is we observed bias. In some cases, like for example, in the use of artificial intelligence systems to manipulate election results. Once it's complete, then post hoc we say such and such election was manipulated using disinformation, which was propagated by artificially intelligent technologies. Disinformation or misinformation is bad enough when it's done without using AI, but it becomes super powerful. The effects of misinformation, the effects of fake news, it's amplified when we use artificial intelligence. So we are developing and deploying these AI technologies, and we are expecting, we are in some senses, we are trying to develop and adapt YA, that is the input and logic and the technologies that are being used to create AI applications. And our expectation is that we will tweak or change YB, which means we will change the NLP models. If the NLP model is displaying bias, we're going to change those models. We're going to de-bias or unbias or take the bias out of those models, which is essentially saying you're going to manipulate the data from one perspective. That could be the conclusion. But the question is, do you have the basis to do so or not? Do you have the justification to do so or not? And we are using, therefore, going from YA to YB to YC and YD to address problems in XB for which really the solutions exist in XA. If the solutions exist in XA, which is philosophical foundation, understanding the nature of AI, understanding the limitations of AI. If we cannot understand the limitations of artificial intelligences, the abstracted limitations of artificial intelligences, unless we understand AI philosophy better. We can understand the limitation of artificial intelligences in terms of what is it that an app can do. We know, for example, a computer vision app cannot hear or play chess. And we can also establish within the aspect of computer vision itself, we can establish certain boundaries. But that is a trivial issue. We are simply talking about measuring and establishing capability boundaries. That's not what I'm talking about. I'm talking about fundamentally, from an abstracted view, what are the limits of artificial intelligence? For example, if we were to conclude that artificial intelligence is incapable of intrinsic meaning, of developing intrinsic meaning, and therefore incapable of holding human-like beliefs, then by definition, artificial intelligences cannot and should not be used for judicial processes. except for basic tasks like search and find or something of that nature. But it cannot be used as a recommender system if we were to philosophically establish that AIs are incapable of human-like meaning. Why should we use something to influence human judicial thinking and human judicial decisions, or even granted autonomy, as some have suggested, when it is incapable of creating and holding meaning and beliefs the way the human mind does? So yes, there are efficiency advantages. We have a backlog in courts and there is a need to process it, but that does not justify the kind of risks that are produced by using applications without a strong philosophical foundation. Most of the emphasis in AI, it's like a gold rush. Everyone is madly rushing into artificial intelligence, but most of the emphasis unfortunately is on coding. And I don't say that we should stop coding. All the more we should code, and there should be more people getting into coding. But my point is, we need to foster, we need to cultivate serious attention to AI philosophy. There should be a balance. Those philosophical foundations will then help us to generate better applications. We will be able to set better goals for the AI applications. We'll be able to set better expectations. It'll be more sustainable, and it will result in greater good. One of the key aspects of this whole thing is policy. How do governments deal with the development and deployment of artificial intelligences? And then there's also, how do lawmakers work on this at the micro and macro level? I think at the macro level, there's, in some regions especially, there seems to be some feverish activity that's picking up, whereby people are saying, AIs are powerful, AIs are invasive, and one of the concerns is privacy. And we are still using the information systems, the information age mindset to deal with artificial intelligence. That's not going to work. The technologies of the internet era, the technologies of the information age are significantly different from artificial intelligence. Artificial intelligence is a different paradigm in terms of technology. And the reason I say so is because in the information age, we had a whole lot of information, and human intelligence essentially became more valuable in the information age. Human intelligence became more valuable. But fast forward a decade, and we are at the cusp of an AI revolution. Some experts say it's already here. Some experts say that we are entering into it. Some experts say we are just about to enter into it. Whatever it is, the general feel is that we have reached that tipping point. The difference with artificial intelligence is that artificial intelligence replaces human intelligence. It's not about you need more human intelligence to use artificial intelligences. But in the AI, let's say we look into the future, a decade ahead, a couple of decades ahead, we are talking about a technology or a cluster of technologies that will replace a significant percentage of human intelligences in terms of their economic functions in particular. And then power will tend to be more concentrated with those who create, control, maintain, and develop these artificial intelligences. And what is going to safeguard us is policy. And policy which is grounded in AI philosophy. Policy which is not grounded in AI philosophy will not lead to sustainable human good. Policies which are looking at a technology, there is a computer vision application that's come out, let's regulate it. And here's some other machine learning algorithm that's grabbing information from people and learning to manipulate them, and let's regulate that. That approach, some of those rules are needed, and I think that's good and useful, but it's not sustainable because those technologies keep changing, and there is no way that these policies can keep up with the rate of change of technology. So the old strategy that we used with previous era technologies is not going to work with artificial intelligence. It misses the point completely. You need proactive policies, policies which go ahead of the technology applications, policies which are based on AI philosophy and have the capability to serve as an umbrella policy, as an umbrella set of rules. I'm not in favor of over-regulating. Well, I'm not talking about the quantity of regulations. In fact, using AI philosophy to drive policy may lead to fewer rules and regulations, but something that's more sustainable, something that more accurately covers a trajectory of AI applications rather than individual applications by different AI giants. It is very important to have a philosophical understanding of artificial intelligence. And for that, you have to go back and also first study the intelligence itself and the nature of intelligence, and in particular, human intelligence. And that then forms the basis. Once you have a clear understanding of human intelligence, then that is the best resource for you to manage artificial intelligence. An absence, a poverty of an understanding of human intelligence then leads to a weak, siloed, unsustainable approach to developing and using artificial intelligences. So if you have listened to this and come to this point, you're on a journey of learning and engaging artificial intelligences, and I wish you the best in that process, and I wish you the best in your learning journey, and hope that you will take it upon yourselves to dive deeper into artificial intelligence philosophy and its implications for human society. Thank you.